Okay, hello. So yesterday stuff happened and so I stopped early. I didn't save the video, which we do be like that. Let's make sure that the stream works first of all. Yep, so it should work, everything perfect. Okay, so we will have here documentation and here we will have the actual code. Yep, okay, so what is the goal for today? Well, first of all, we have to verify that the demo we made yesterday of the environment works. So let's go here and just write, yeah, okay. So, yes, poetry run, yeah, it's here, but now it's in demo. Okay, so yesterday, this will result in an error effectively because I haven't updated. Yeah, so I fixed that earlier today, when I pushed the update to Pipey. Yeah, so 3 log update. This should work. Oh, if I remember, it needs the flag. What? What the hell? Ah, it's automatic. I confused it with this. Okay, so we should run this. We should update. Wait. This is going amazingly well, it do be like that. Okay, so everything has been updated. So now if I go inside the demo folder, poetry run, Python MMLU, okay, we should get something that works here now. Am I too dark? Let's try something. Yep. Okay. Anyways, so we have a better result. We have the warning because I have deprecated that thing. Okay, so now we have everything working. So what have I made? Yeah. Okay. This is the H params. This device. Okay. So everything initializes right now. Let me open another window for. It should be here at the ends. Yeah. Okay. Okay. So MMLUnaire. So again, I said it yesterday, so I'll say it again today. What we're trying to do is to make a fake Who Wants to Be a Millionaire game. We're making natural language reinforcement learning, so we care about we care about gamifying something that uses natural language. And Who Wants to Be a Millionaire is a good one. Another good one is like a trading card game like Hearthstone or Magic the Gathering or whatever later. So for we care about the MMLUnaire, called like that because we're using the MMLU multiple choice benchmark to do this. And so yeah, this is its source first. It's open source equivalent for non-commercial use, so I don't really care showing this the entirety of the source code. You can find it also like once I publish it on a Git repo. Okay, so what we want now is we have the agent here, and the way that things work for these kinds of things is, if I remember correctly, I haven't written an agent in like a month or so. So we have the agent, we have the environment. So now we need to start by saying that the observation comma info here, but we don't have any info, is equal to the env.reset. And let's go very, very slowly. I'll open a third window. Yes, this is how it should be. where here we will run everything, and on the right one we will be able to make any updates. Because I'm not using an IDE with an integrate terminal. Well, it do be like that. So okay, so let's run the cell here so everything works. Let's clear this and on MLU, and so we should see. Oh, I didn't. Well, okay, let's finish this. So, because if I remember correctly, here, yeah, we just return the state, and so this should return natural language description of the state. Should be a question, a possible choice, and some scores and stuff. Yeah, so we have this here. Which of the following ideas have become mainstream within human security since the Human Development Report? And the agent reads all of this, and yeah, so let's write that effectively. Let's do the very simplest first step of agent.choose. I need to install a language server. Do I not have that? Wait. Install PyLSP. It should be right. Yep. Okay. Intermission. Okay, so this should be installed. So now let's try. Does it fix itself automatically? Helix MMLU. Okay. It's agent dot. No, it does not. I think it's choose action, right? Is it? Okay, so here we go with the documentation. Okay, so let me very quickly. Let's try not to leak anything on the live stream, but you know how it do be. Okay, so we are here on the agent. So here, this is the electors. It's open source. You can find it. It's source first. It's not open source because the OSI has a soft type of trademark on the term open source, even though they don't. But who am I to say anything? Yeah, so let's check. Yeah, choose action. Perfect. So we pass in the state and from that we get an action. So this is the action. Let's see that it makes sense. Action. Okay, so before oh yeah, okay, I passed in the action space for that. Perfect. And so here, clear, and let's run. And let's see what happens. Let's hope. It should be an integer. It is. Wait. Should it be? What the heck? Okay, first of all, let me. I do not need the verbosity right now. I do have the warnings, but I don't really care because I just want. I mean, I can change the. So it's a tuple, huh? What have I done wrong? It's returning action probes value and the bending. Okay, yeah. Okay, I forget. So this is natural language. I mean, obviously you have the action, the probes, and the values because we're doing proximal policy optimization. But I forgot also that we return the embeddings, and so I saw like this monstrosity, and I'm like, what the hell? But no, these are the embeddings from the encoder, because if you see here, we have we encode the state using the tokenizer, and then we throw it to the encoder, and we get the embeddings, and we return them, even though it's not so standard in reinforcement learning, because when it comes to the learn function, we really do not want to have to compute everything there. And in general, it's not that big of a deal, but for me and for small, like if you want to run this on a computer, like my computer has an AMD GPU with 12 gigs of VRAM, and so if I run something on that, I need to be as efficient as possible space-wise, so I cannot have the encoder running while all of the gradients are computed and in memory. I need to do that. I need to separate the two because it just gets too big, the memory, because like that tensor is huge, and then we can't have that tensor with the computed gradients with everything. And so I decided that it's better if we return it on the choose action. Anyway, so we have action, comma, probes, comma, val, comma, embedding is equals to that. And so now we should see, no, here, we should see a single integer, maybe a PyTorch tensor, but with an integer. So yeah, it shows action 3 out of the 4. So if we print the statement, the observation also, wait, yep, print. Okay, so we can see what it shows effectively. It will be wrong, probably, because it's not trained. We're starting from 0. Okay, so question which of the following ideas with the one we saw, and it shows number 2. So 0, 1, 2. Focusing security only on violent conflicts is too restrictive. I don't know if that's the correct answer. Honestly, I have no idea what any of this means. I don't know the human development report. But that's the one that the agent chose. And so now we have to move onwards and forwards with the rest of the environment, the training grounds for the MMLUnaire game. So we have this. And then now we can start working on the what happens afterwards. What happens afterwards is that the environment has to make a step based on the action, and that returns so if we go here, the step returns the new state. So new observation, reward terminated and truncated, and all of them are here. Normally this would have also info, but we do not have the info, so we don't care about it, honestly. The reward, yeah, okay, so yesterday I went through like why it's money, because it's Who Wants to Be a Millionaire. So hopefully it will make this AI will make $1 million effectively. The reward structure for now is that once you make a correct answer, you win a single money, and if you lose at any point, if you make a wrong question, you're out, because that's how they do it in the game. So you have 10 questions, if I remember correctly. Okay, yeah, you can choose the number of questions. We have 10 here because I don't define it here. It's just, yeah, everything default. And so we have 10 questions, and the first one is always this one. And hopefully you want to train it on a specific set of questions. You don't want to train it in general. Because if you just throw random questions without a sequence of the questions, so if you just shuffle randomly, effectively you're not training a reinforcement learning agent, because you need to walk on a graph. You can't just have a stochastic process where you're just walking randomly, where you're picking random questions. So you need to have continuity. Then the problem with this obviously is the fact that it can just converge based on the oh, this is a question, this is the answer, I don't need to understand why. So here it might learn that, for example, let's say that question 3, answer 3, all of these options is the correct one. So it can just see this, it can get the embeddings, and the embeddings, based on the embeddings, it chooses this, but not because it understands the question or the state. In general, it just knows that, okay, I see this, I do this. So it's like how you do speedrunning, where you don't actually take in the game, you just know, oh, I see this thing, I press this button, rather than, oh, this is an enemy that I have to deal with, etc. You don't need to strategize, you don't need to do anything. We could make it more complex by giving the agent the options of like to call a friend, which would maybe not, but like that could be another AI just waiting in the corner, maybe like a small LLM. Or other things, but yeah, so this is a thing. I think rather than 10 questions, it would be better to have like 10,000 questions, more likely, but like it always has to be on a given order, I feel, to train, because otherwise you just, there is no, so the reinforcement learning works as a Markov decision process, so it needs to, given the exact same state, always have the exact same outcome. It needs a sort of deterministicality, in the sense that you should be able to calculate the future based on the current condition. And if you just shuffle all of the questions randomly, you don't really have that. So it's we're walking on like a piece of rope essentially over the hill. Anyways, so we have that. We have the new observation, rewards, terminated, truncated, and everything like that. So yeah, so what's next? We have this. So now we want the agent to save all of the information. So that should be, I don't think I have defined it here because I call it from a self.memory. Yeah. So we have loading. Okay, memory, but it doesn't work very well. Okay, thanks Helix, or myself probably. So we want to store to the memory, and we want to store the observation, the action, the probes, the val, the reward. I have dance, not okay. So how can I make that? How can I combine it? Even though like I should probably change it in the library, in the electors library, which I will do maybe tomorrow. But in any case, I don't really want to do it now, even though it would not be that difficult. Honestly, I might do it now. Yeah. Okay, so yeah, okay. I mean, I'll just do it like this for now. Oh, I don't have. I'm on the desktop, not my laptop. Okay, so objects here. Okay, git clone this. Yes, okay. We're waiting. Bada bing, bada boom. It's loading a lot of things, and I'm pretty sure at some point I sent weights of 100 million like sized model or something, and so I might have to redo it, or I have to clean it up somehow. I'm not very good with Git, I'll be honest, so I don't know how to do it exactly. But anyway, yeah, so okay, so electors here, yeah, so it is in the PTO memory. Wait, memory. So we at the memory thing, we don't want self-dance. Do we? Okay, let's start. Gated terminated. Okay, so let's fix that. Have action for build these values. So we want this. Yeah, okay. Come on. Okay. Gated in the same order, right? It does matter. So reward, yeah. Gated, nated. Gated, riveting, truncates. Let's do that. Terminates and truncates, because we're passing the other thing as a like input here, and it would be a bit confusing. Also because of the color coding. Truncated, yank, paste, yang, terminated. Yeah. Terminates. Okay, and here the clear should be the same as the beginning, so we should copy, and here. Okay, so in theory, truncated, terminated, so this should work because we have the truncates and terminates everywhere. Remove. We don't have any more dones. Oh, I don't know. I might need to do like some funky stuff right now. Yeah, okay, git. Let's try. Use Let's try and push. Aha. Okay. Well, I cannot do this here right now. So instead of doing that, I'm going to go here and say, you know how you're using a local path. We're going to also use a local path, and I will push it later, because right now we care about the development of this thing. So it should be wow, very so nice. Yep. Okay, loop equals true. Okay, so it should update now. Yep. Okay, perfect. And if we're yeah, demo. Oh wait, no, we have another. Okay, you're done, so you can close. And yep. Okay, you're the MMLUnaire clear. You should. Okay, and here I was helixing. Okay, MMLU, yeah. Okay, so helixing. What a nice way. Terminated. Okay, do I have it in this order here? I should change it if not, because I truncated, terminate. I mean, okay. So and now here also, yank. It should be here. Oh, what? Yeah. No. Come on. I'm trying to use the keybinds, but It's a bit weird sometimes. Yeah, so let's clear, let's run the MMLU, and hopefully this works. Oh wow, I'm looking very dark. Let me try. Is it this way? Yeah, it's this way. Okay, perfect. So you can see me a bit better. What? Oh, we don't care about the observation here. Oh, we don't. We care about the we care about the embedding. We care about the embeddings of the entire thing. And also, why are you breaking? Action, data, answers. Oh, question, choice, and oh, it's a single answer, not answers. Okay, so this should work. I mean, we can only hope, I guess. Local truncated, Oh, we don't have it? Yeah, because we doesn't have the so yeah, okay. So did terminated equals with false. Okay, so now once again it should work in theory, hopefully. Let me get some water. I have it right over here. Big chair, right? I know. Okay, so it works. And we have the proper thing. So we have the warnings, which I can fix by going .adam. Let's go with Adam. Import torts.optim as optim, and let's okay, I think it's this name. It should be this. Okay. I mean, we don't pass anything in, it just goes to Adam anyway, and we don't have this. What do you mean? Wait a second. I have it working on the. Wait. Here are lectors. The test. The tests are not tests. They're. I don't know what to tell you. Optim. Yeah. Towards optim as optim. What have I done wrong here? What the hell? Hey, optimizer, optim.adam. What am I doing wrong? It should be in if is instance, at line 69. Nice. In the value network. So here? What? Why did it not break here? Why is the actor happy? Okay, well, let's go. Let's go on a quick bug fixing adventure. So this is the policy. The policy just works if it's instance optimizer is subclass value. And I have the module here, so I have only these things open. Yep. Okay, so let's open a new window again. And let's be lectors, okay, the lectors, networks. Let's go. Actually, I'll make it full screen here, so I can do this and have value. So I can do a side by side. So this is the policy. Warnings, yeah, torch, and then. Though, do I not have? I haven't imported. Okay, so let's copy and. I mean, I just yank. Yeah. Okay, and let's go. Like this, like so, and do this, and this should work. And that's such a. How did they not? I don't know. Anyways, I'm very good at this. Obviously. So let's try again. Yeah. Okay. Yeah. Perfect. Everything works and everything is stored in memory. And let's try. Let's try the learning of the agent. If that works, then we're in a good position to then like create the for loop for the training loop. Too many values to unpack, but I'm using the embeddings. So it's because it's done. Yeah. Okay. So let's go back to PPO and Helix agent. So dance are okay. Here it should be gated are terminated are and yeah. So we're now with dance int. Okay, so rather than doing that, we could have, how do we do this? Because you would have terminated or truncated. I mean, I can just literally do an or statement inside of that. So that's what I'm going to do. Terminated. Let's yoink here. Or int truncated or terminated. And where do we have done anywhere else? Okay, so you're looking behind the scenes now. This is the proximal policy learning function. If you have done proximal policy, it's it's, I mean, it is something. It's supposed to be one of the simpler ones, which is why it's so common. But you know, it do be like that. Anyway, we're done with this, so this should work now. Because it's an or. Yeah, if it's one or the other, then it should be valued one. And nothing else. Do I have? Oh yeah, I don't have it to be verbal, so verbose rather. So we can't really. I can hear the computer spinning, but like, let's get a nice confirmation. Yeah, it did finish correctly. So we do have the full thing that the agent needs to do. But yeah, okay, confirmation. It's running on the CPU. You can see here that everything is on the CPU. 768 DIMMs, and in total we have 64 million size model, which is a very small one. But okay, so now this works completely. We have everything done. So we have the observation being this, and now we need to make a training loop out of this. So this, I need to move this somewhere else, like honestly, because it's very ugly. But yeah, for now, this will be, yeah, okay. So here we define training params. So this is going to be the number of episodes the horizon, which how often we trigger the learn function. So let's do 3 episodes. Let's do something small, because I'm not going to just look at the camera and like just be sitting here like this waiting for anything to happen, obviously, right? We just want to see that the loops work and that everything works correctly. So the number of episodes, let's say 10. Horizon equals with so it's 10 questions, but until one is wrong. So the first one will be very wrong very often. So let's say that the horizon's every 5. I mean, this is obviously bogus. These are very small numbers, and this would lead to I don't think it will train to any capacity or to any extent, honestly, but it's still a good sanity check that things work, in the sense of like the code is correct. So we'll see how we do later about that. I might, like, obviously at night I might just patch it. I will patch it here to show how you would set it up for AMD. I don't have a Mac, so I don't know if that works on a Mac. I don't have NVIDIA, but I would assume that NVIDIA is the simplest one to make it work for CUDA. And yeah, so the goal, the rest of the stream here will be finishing like this as a proper loop, and then making sure that it can run on CUDA, on AMD, and then at night I will let it run on its own, and hopefully we have good results. And obviously, here the step, the reward function is not good. It is not a good reward function. It's a very simple of, if you're correct, you get a reward, and if you die, you die, essentially, which does not give the agent time to learn. So we might try and improve the reward function a bit also. We'll see. Anyway, so we have here. Okay, so we have the number of episodes, and for I in range episodes. Yep. Okay. Now you start with the LSP working, the autocompletion. So we have, obviously, okay, while not truncated or terminated. I mean, it's the same as truncated or no, both are false. So env. Do I pass it as a global? As a self? Let's see. Yeah. Okay, so we don't. So let's do that. Health. Okay, and okay, so we don't need to do this here. Let's move it. Should we move it here or the init? Let's move it to the reset. Yeah, to the reset, obviously, because we want after we reset everything go back. So here we do observation equals with env dot reset. So we have the initial step, and then while not, we have the observation passing in, we have the action being decided, the new observation, and everything being based on the environment moving a time step based on the action. And then we have the memory storing, and now here we can say that since we don't care about the observation here because we get the embeddings, I don't really care to say new observation, because at the end of the day we're just going to cycle through. So the observation becomes we have the observation, we have the action, we have the step based on the action, and then the new observation is the new state that we're at. Maybe I could do something here. Maybe like question choice. No, okay, we have to do this first of all, and second of all, we can do a very funny thing, which is like if the state is, oh, you died, essentially, but I'm not sure. Does it work? Okay, well, let's see. I'm not sure. So first of all, what we want is this thing here, rather than returning the question choices as a tuple, because that's not what we're handling it inside of the env rather than outside. So everything's under the hood. The state and the money truncated intermediate. So this is the thing. Yep. Okay. So what we can do, so truncated and just return I mean, honestly, we can just say like you lost. That was a correct thing. Let me fix this and say like, yeah, we could just give the state as okay, let's put everything here actually. Yeah, so so let's put here, because they lose a game, so everything has to end there. Okay, so if self-terminated, maybe we can add here a state also, like state is equal to congratulations, you are now a millionaire. And we can say like, yeah, you get so much money because you made it to the end of the game. Congratulations, you're the grand champion of the arena by Azura. Now a millionaire. Yeah, so we don't need and then we can say like score, because we want the score, like we want the tokens that will be here to be associated with the reward. So the score is going to be self.money and the plus 100. It should be a huge reward that really incentivizes the agent to make it to that point. Yeah, you're now a millionaire. The end. And you have that. So if is the number of questions, yep, okay, and return, so we want to return stuff here, yank. So we want to exit here in the if statement, and if otherwise we want to return at this statement. I mean, there must be a more elegant way to do this, but right now, I mean, we could do conditionals only for the state, because we're effectively, yeah, okay, so what I will do is just I'll do conditionals, yeah, sure, else here. And we don't want that returning, and we want this to be on the same level as everything else. Okay, if they make a mistake, they lose game. Yep, truncated, true. And we don't have a state defined, so state equals with and we have that the score. Oh, you did, like, you made a mistake. You get like a bad, a huge like negative score. Yeah, okay, but I don't know if it will do anything, honestly, because it's at the game Who Wants to Be a Millionaire. You do not do that. Like, you finish and then you're you're just no, you lose money. You go to the level below that you're the last safe spot or whatever. You know, it do be like that. Question. No, we don't have a question. You lost. You suck. And we could have it like this. You know, you lost and get out of here. Get out of here. Okay, so we're done with this, and so we have the observation, we have the truncated, we have the money, we have everything. Yeah. Okay, so let's say that you survive with whatever money you have to your name effectively by doing that. Okay, so we have everything here, and so now we have if idx. I mean, how do we do this? Now, okay, so now we need to tell the program if x time steps have passed, if x steps of interaction have passed with the environment. So not per episode, but in general. We want to run the learn function. We don't want to run the learn function always, because we are storing we're storing all of the experiences to do offline training, as it's called. So the way that we want to do this is to have a global counter. So what I could do is to say like time steps equals to 0, and then while not here it goes, it's on the first one. I mean, it doesn't really matter, so let's do it here. Steps, it increases by 1 on, so mod horizon is equal to 0. This is the mod, right? Or is it 1? We'll find out. I mean, let's check. Module operator, it's 1. What is 2? Yeah, okay. I mean, yeah, whatever. Okay, we're happy with that. Yeah, okay. So we have modulo. Is it? I don't know. Anyway, we have that then do this, and let's, for a sanity check. Yes, and I do love print debugging. All of my friends support print debugging. Wait, okay, so I forgot a little statement on MMLUnaire. So not here. Okay, let's close you. Here. So. Oh yeah. Okay. Okay. So now this should work, and we should get like I'll use Takadem to check. I mean, we have that. We have the yeah, I forgot I had the verbosity on. But yeah, so we see that in theory it should be on the, yeah, very quickly, but like okay, so now let's help with the let's verify that things are not verify, but let's keep track of things as they happen. So let's add Takadem, and we have that, and now here we can say them here. Okay, we could do it for the while loop. I'm not going to, because I'm too lazy to do it, because I need to like spend a solid 5 minutes to find how to do it. I've done in the past, but it's not as easy as just while not Takadem, because like obviously it doesn't know when the end is, so when is the 100. But yeah, we should see let's have a very small print statement. Print f string question, and here is the env idx. So it should start at 0. Oh, I did that already. But okay. So it should be yeah, question 0, and it got it wrong, and then it's training. Amazing. So I assume that on the very first, yeah. Okay, so what we're seeing now is that the agent is just failing the first question, but because the horizon is so like small compared to the number of episodes, also it's just training on the single, like on the 5 same initial observations, and will never. So yeah, okay, so what we need to do extra stuff. Let's say that I like 1024 for the horizon, but I need to do like this. I mean, I can set it running while we're working on the AMD Torch integration, which I love so much. It's totally not. Why is it? Because it's. Yeah. Okay. Let's not actually. Let's do this here, and I mean these are the metadata sort of. So let's do this, and then clear, and then let's run this, and so now it should start. Oh, it got the first. Yeah, look, it's answering 2 questions before it fails. It's, you know, okay, so because it's spamming a lot, I'll close this and I'll just let the whole thing running, and now we will figure out together torts for AMD, which I have figured already. Actually, I'm lying. It is in here. It's this thing. So let's go. I have that also, so which I need to use. So yeah, okay. So we open this amazing thing. So what happens is that Torts has Torts for NVIDIA CUDA drivers as the package Torts, and they also have the ROCm drivers for NVIDIA, but they're not in one package. So we need to go to their website and download. So we need to go to torts.org and then go to wheel ROCm 6.2.4 for Torts 2.6 and blah blah blah, and get the wheel and then download that. And to do that, we need also to add the supplementary repo here. So this should do the poetry. Let's lock the file, the new thing. Okay, how are you doing? 144. Okay, I mean, it's going pretty quickly, mostly because it's like losing on the first or the second or the third question, because it still hasn't learned anything. I could do the 256, but so it has more than one training. Yeah, let's do that, because this does not make sense. This is how I code, by the way, which is very insufficient, because I think of something, I let it run, then while it's running I say, oh, I did something stupid, let's drop the entire thing and start again. Instead, what I could do is think about it for a second before letting it run, realizing, hey, maybe I'm stupid. Let's do 128, 256, yeah, 128. So we have lots of, I mean, now that we're done, you can also just do the torts. So to do the torts, this is for another like type of demo thing. We care about this nice thing, which is, again, Torch does not really, like, they support Rockwell, they support AMD, but you have to do some extra stuff. I have an old GPU. I have a 6700 XT, and so I need to do these things also, which is a bit different from, like, newer AMD GPUs do not have this issue. You don't need these two things. I don't know if you like need the second one even right now, but like, oh, whatever. So let's clear this, and okay, so now we have this. So the device is, what is the incantation towards in general? Wait, port towards, and we could just keep the optim here, but whatever. So towards, so the incantation, the spell that we have to learn to always know by heart is CUDA if torch.cuda.is available else CPU. So forever we know this thing, and ever and ever. So now we can device that equals device. So now the agent should be in the GPU, and let's try, and let's hope that it works. I'll tell you if my GPU starts whining, and we will see on the verbosity also. Yeah, on CPU, no, it does not work. Do I need to do? Wait. Do I need to do this then? Does it have to get passed? But everything should be agent has no, yeah, obviously. But how do I? Because if I remember correctly, right? Everything should pass to the. So we have the device here, which is like, yeah, the CPU, whatever. Device, yeah, but here. Okay, wait. So probably it is an issue here, although I hope not. Oh, did we not update? I don't think we updated. So yeah, okay, yeah. Okay, so I'm just forgetful. So here, entry update. When we do this, we should get the proper version of Torch, and so then we would be able to pass to the GPU everything. Yeah. Yep. Okay. Cool. Huge wall of text. Anyway, in the meantime, we're just waiting for everything. Yeah, we're downgrading Torch, we're downgrading all things because Torch 2.7 came out. I have no idea what they do there. I'm using 2.6 most of the time. Anyway. So, as we're waiting for this, how is your day? I hope you're having a great day. Hope you're having a great afternoon. Most of the stream we had 2 people. I assume these are the people I told about me streaming. Yeah, okay, we're done. And let's go here. And let's run it. Oh, again, the second viewer. Hello, second viewer. Yeah, so now it should run on the GPU. So we did the CUDA, the rock magic, so that things would work. Yeah, now it's taking a lot longer to run actually because it needs to load everything into CUDA, and I hope that everything works. Obviously, when you look at the hyperparameters, they are not good. The number of heads is too big for the number of layers. GPT-3, if I remember correctly, had 92 transformer layers and 92 heads. My GPU cannot load that. It's too big for my GPU, and it's taking a very long time to do anything here. I don't know why, but okay, let's give it some more time. It's cooking something, you know. But yeah, so while we're waiting, I'll go over the hyperparameters. So the number of epochs is the value that the training is, like how many times it does the learning effectively. So inside of the learn function, we call the loop for the number of epochs, and what that loop does is that it replace what we have stored in memory, run in a random order. So it randomizes the current state, and it tries to calculate, oh, this is the current state, is it a good state, and which action should I choose based on this state. The batch size is how many per epoch, how many experiences, how many states are trained on per epoch. The policy clip is the PPO clip, proximal policy optimization. The actor reads. So there are some papers that talk about better performance, better continuous learning with reads regression in reinforcement learning. It's not a common thing to use reads regression in reinforcement learning, but it is something that has been tested to work to improve plasticity and to improve long-term learning and reduce catastrophic forgetting. So that's why I give the option on my library. The grad norms clipping, because they, gradients be exploding. And then we have for the actor and critic, the hyperparameters, the optimizer, transformer layers, the number of transformer layers, and then the specifics for the transformer, like how many heads, what's the forward expansion, what's the dropout, and this is a gate which effectively takes the embeddings of the state representation, and it passes everything. So during the neurons, the actor and the critic are transformers, so we feed them the embeddings, but then we want to just get a single action, or we want to get a distribution of size, the number of actions, so the action space. And to do that, we need to pass it through a gate so that the dimensionality collapses, but collapses in a good way, in a smart way, rather than just having a linear network, like collapse everything into a single value, or like, yeah. So we have a gate, which is another self-attention layer, when you can set the number of heads here. And yeah, this is all. I don't know why it's not working here with the CUDA stuff. Let me check the system monitor actually. Yeah, okay, so if we go to history, the GPU is vibing. It's not, I don't know why. Okay, anyway. What the? Why are you like this? Okay, I will try again. Yeah, okay. Okay, so what will happen now? Will it work? And it doesn't make sense for it to get stuck for so long, honestly. And the computer is like ramping up. There is something happening, but we're not getting anything. So I'll just cut it. Wait. I'll just close the. Yeah. Okay. Well, it's hanging, so I don't know why. Anyway, I'll try and take it for like another day. For now, we go back to CPU. So let's just verify that everything is running, because we didn't change anything even, but so everything should work. So yep, everything is working as intended. And we can see, like, we can try and say that, like, oh yeah, so there's 3.5 5 iterations per second. So if after the training, because right now it's not learning anything right now, it's just bashing its head into the wall. This is the exploration effectively. It's exploring the state, and it's collecting experience and memories. So now it went into the learning, and now it trains on the experiences that it has gathered, which is why it's called offline. It's trained. It's the learning is separate from the exploring. And so this is how it learns how to. This is the very slow one for the CPU, obviously, because here is where it does all the gradient computations. Before it was, so if you think of it in the sense of like supervised learning, because reinforcement learning isn't that hot in general. What it was doing before is that you were just giving the data and was just predicting, and so now we are actually doing the loss calculation and the loss and the gradient update and the optimizer steps and everything. And after the learning, after the number of epochs is done, learning should have whatever, fixing the strings here, like in the verbosity. So after this, it will go back again to not calculating the gradients until the next learning. So effectively what we're doing is that we're collecting experiences, and then we train on the experiences, and then we go out and collect again new experiences. And this provides a lot of stability in terms of agent learning, because if it does have a very weird experience, it's lost in most of the other experiences. It's not it will not affect the gradients immediately. So by you doing this, effectively we're providing a lot more stability in the training compared to doing it online, which is just running it always, which I think is what Q-learning does for sure, but Q-learning doesn't use neural networks. Like some earlier earlier actor-critic methods did. So we're waiting for this effectively now, because we're slaves to not having a good NVIDIA CUDA GPU. We're effectively, it's done. Now we would need to go and fine-tune, but in order to fine-tune, we need to be able to run it. In order to be able to run, fine-tune, I mean the reward structure. Like, this is the thing that I feel most insecure about, because obviously, like, losing immediately does not make sense, and getting only a single doesn't make sense, because in Who Wants to Be a Millionaire, in Who Wants to Be an MMLUnaire, I should say, which is the name of the environment here. We want to be close to how it's done in actual life, so we need to go through how the rule set is. Like, okay, you gain this money, use this money, and then so it should go like here. When you make a mistake, you should lose money and go to the nearest amount of the floor, essentially, which, it should not be very difficult. I mean, I might do it immediately after this training. We're waiting to see if it improves over this 3.6. If it goes to 4 to 5, then that means it answers more than 1 or 2 questions. It answers on average more questions that it answered before the training. So we are improving. I don't think it will, because again, the reward space, the reward function, is very badly defined, in my opinion. It's a very let's just make it work type of thing. But I don't really know how to make a lot of changes and still stay true to the actual Who Wants to Be a Millionaire type of environment. But anyway, it's almost done. We're about to find out if what we have been doing makes sense or not. So 3.6 is a thing to beat, and at 14 seconds per iteration, my god, I need an NVIDIA GPU ASAP. So yeah, it's falling down, it's going to 1, this is not good, 3, 3.5, 3.6, no, it doesn't seem, it seems like it didn't improve at all. It seems to be doing like a bit worse if I, before it would get to 3.9 at some point. Yeah, so it's all fine tuning. So once again, you have like this thing, which is not all of the hyperparameters you could have. Honestly, you could have. Let's see the number of hyperparameters, because let's go to the docs for this. Let's go here. This is the really cool website that I have made for the documentation. It's a Hugo. It's a Hugo static site for documentation. The theme is Hugo book, and I got that, and I used that. I made some modifications, obviously, but still the entire site is under MIT license, because that's the original theme license. So you can have the information within the license. You can see the license here. It's the source first. It's not open source. It's not free software, but it's source first. So it is free software equivalent for non-commercial purposes, and then for commercial purposes it has a fair compensation clause. Anyway, we're here to see the amazing hyperparameters, and it's just glorious the amount of things that exist. I need to change the optimizer stuff, but yeah, all of these things are things you can fine tune, you can play around with, and all of these could in theory affect how it performs, and it's a lot. Like when I was doing my master thesis, I would do proximal policy optimization, and it would just be not as much, and it would be still very annoying and stressing and tiring. I mean, you get an intuition about what things matter the most. You can play around with that intuitively, but yeah. So it's doing another learning. Yeah, so it fell on average, even though this isn't the true average, but like it's more closer. It was closer to that from what I saw. Let me make the chair a bit. Yeah. Okay. So let's try now, and before I end the stream, because it's been 1 hour plus already, and it's been a bit tiring mentally to talk. Talking, I don't mind talking. My friends know that I talk a lot, but like, yeah. But the issue is that we want to keep and maintain like top quality mental capacity, and thinking and talking and working things out has been like a tiny bit tiring, if I'm honest. So as is like natural. So yeah, let's try and figure out who wants to be an MMLUnaire. Let's change that. I mean, okay, no, we have to feed it the tokens, the semantic embeddings, and saying MMLUnaire here will not make sense because the encoder has not seen that phrase before. So we want to have a different state here. We want to have a different state if you lose, where we tell the agent that you suck. The agent sucks. The agent is bold. I don't know. Get the fuck out of here. Yeah, otherwise it's just a score and the question and the choice, as we saw before. So the reward structure should be, let's go here to the init function, and let's try and set the money levels. So the money levels should be, well, let's see the actual like levels. Who wants to be a millionaire? So obviously this is legally distinct from Who Wants to Be a Millionaire, the game that we're making. Crore, yeah, okay, different currencies. So the original version. Okay, hello, my guy. Okay, no. Who wants to be? No, no. So we care about the not stuff that is here effectively, as I understand. Seating scan. Oh yeah, I remember that. This couple here knew all of the answers, right? Somehow, and somehow another friend of theirs who was a professor had a very bad cough the day of the event, and he would allegedly cough at the correct answer. And yeah, so they would win because they had a professor friend who they allegedly won because of that, because of the guy having a bad cough when the correct answer was read in each question. So you'd leak here, etc. But it does not seem to have any information here. So let's go here. Does it have? Is it this? Okay, it's different. Not production. No. We could set our own. Okay, yeah, are used to 0 for tier 1, 2, and 3 for tier 3 questions. Okay, so we can do the different tiers. So, okay, so let's have this guide here. I know it's white. What can you do? We live and we suffer. Let's see, can I do it dark mode? Yes, I can. Okay, well, I like how it is in beta. Like Wikipedia, come on. Wikipedia has a lot of money and they have a very basic website layout. And they are still struggling to do very basic things when it comes to development. Anyways, so it was $0 money. Money. Okay, so money tiers is could we do like random selection of questions? It doesn't really matter, does it? 0, 1,000 and 32,000. Maybe we remove the thousands because we don't want this much difference in let's do 10 and 32. Let's do this. Let's do hundreds. It's $100 $100 and $322 respectively, and we remove the hundreds. But then it's like, how do you do this? We need more spacing. Okay. Okay, let's do our own thing. Let's go for 5 and let's go for 3 and 7 because we're doing 10 questions. 7 and 3. Okay. So or we just don't do it like this. Like we can go to, yeah, congratulations, you're now a millionaire. Okay, so we could do money wise here. So if self.money equals 0, and here we set if x equal less than or equal to 3, let's say, then self.money equals 0, and the agent gets a prompt of get the fuck out because you suck, you're stupid, etc., or whatever we want. Okay, else if idx is bigger than 3 and idx is smaller than 7, so if this is less or equal to, so if you get the first 3, okay, no, because it starts at 0, counting starts at 0, so it's not the third, this is the fourth question. So if it's less than the third, or we could do, I would do it like this just because I like how the ligature looks, but it's the same and this is clear. If it's 0, first 1 or 2, then you lose completely. If it's and also look at this, very cool ligature. So else it goes to bigger or equal to 3, so 3, 4, 5, 6 we want to do, not 7. 6. Okay, so 0, 1, 2, you get the fuck out because you suck. You got a no answer correctly, effectively. And if you get at least 3 questions correct, right? Or you get where do we increase the IDX at the beginning of the step, right? Where do we increase the... Yeah? I'm very confused now. Wait, here. Yeah, okay, no, we don't want it here. We want you... here. Yeah, we want immediately after the answer. Okay, thank God I got that. That would be very bad to not figure out, like, bug fixing. So if you have 0, 1, 2, you're out. You're stupid and you get 0 money. If you get 3, 4, or 5, so less than 6. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9. Because you do 10 questions. No, okay, yeah, this is better. So 3, 4, 5, 6. You get money equals with 3. And the state is... Let's banter, let's taunt. I mean, this is the bantering. Let's taunt. You could do better. No, how do you say, like, you could do better? I am disappointed. Okay, so I am disappointed in you. Do better. Full stop, like very passive aggressive. Okay, so this is the I'm disappointed in you. Do better, and yeah. So this is the, and then if it is bigger than 6. So if it's 7, 8, 9, we self dot money equals with 7, and we state so I don't know why. Yeah, you are, let's encourage them here. You're almost a millionaire. I believe, we believe, humanity believes in you. Go get them, champ, and all that, effectively. So yeah, we have these different loss tiers. We have the state representation, obviously. Okay, so we should give the correct answer also if you mess up, so it knows next time. Would that work? Yeah, because we're training. Yeah. Correct answer was, and it should be answer, right? Have I called it something different? Nope. The correct answer was answer. Okay, so let's do that after the taunting. Okay, so let's do here, because in theory this could make this could improve, like this could do a lot of things. This could help the agent realize, like, do better encodings effectively. Could promote the encoding happening. Yeah. Okay, I was lagging a bit. I don't know if it was lagging for you. Hopefully not. So yeah, so we have the money system. So we need an increasing amount of money now, based on the IDX. The IDX goes just an increasing number. We could have a fancy formula for that. We'd have 1, 2, 3, 4, blah blah blah, or whatever. So what I think I will do is leave that for tomorrow. So yeah, I want to stream tomorrow also. I don't know how much time I will have next week, but since this week I do have time, it's very nice to do this, because like I get work done, I do my research thing, I get to scratch my brain metaphorically, which is nice. So what do we need to do? Let's write it here. Actually, so if they make a mistake, they lose the game, but they have like specific falls that they can last at. The correct answer is given so that they can learn from the mistake. Because everything goes through an encoder, right? So everything is embedded, and the agents need to learn, because the actor critics both have their own unique transformer architecture inside of the actor and inside of the critic. So hopefully these transformers learn from the embeddings to do decision making, right? So this is the entire idea behind NLP environments for reinforcement learning, natural language reinforcement learning, if you will. The whole idea is that you give the actor and critic, for PPO in this situation, it's a transformer, and you hope that they can learn through a pre-trained encoder. They can learn actually the state representation in natural language. And so you want to give them the answer, because in this game you give the answer, and also because they might not pick the answer like you want. I don't know. I feel like it's we want to spoon feed effectively, because we're very limited in terms of size that I can run on my computer. So because of all of these limitations, and because we just want to give them the best chance they have, we have the correct choice, right? So why not give it to them? And hopefully that promotes the proper learning. Let's also let's add here to say that this was the correct choice here. Yeah, that was correct. Congratulations, because congratulations. So the thing is that because we're using a pre-trained encoder has semantic representations for positive and negative words, which is why I say you suck, you lost, and get out of here. So because the encoder knows that these are negative, have these tokens, this collection of tokens has negative connotations, and we want to transfer these negative connotation or positive connotation for congratulations to the actor and the critic, so that they can evaluate better their own performance. So they can monitor themselves effectively based on what the presenter, in this case the environment, is telling them about how well they perform or not. So yeah, I think I will honestly leave it here. It's been 1.5 hours, and anything else is just setting up an increasing reward structure, but I don't know how much that will change things, honestly. I mean, it will help the agent promote, like, it will always help. It will, my brain, this is why I'm going to end the stream, but like, what I want to say is, because the agent will see increasing rewards, it sort of promotes Markovianity, but at the same time, if you're using it, it does sort of carry information from the past, is what I'm trying to say. Because you obviously do not, at the same time, you would not have the congratulations text if you didn't have that either. So it might not be as big of an issue. It probably isn't. But yeah, so with that, I'm going to end the stream. 1.5 hours of programming and thinking and talking. So I'll go make some dinner maybe, and see you maybe tomorrow. But like, for sure, definitely, I will see you the next time. Okay, goodbye.